In this video, we're going to look at how we can improve the incoming collider geo to make that better for our simulation. And the main thing we're going to look at is how we can deal with intersections when the collider intersects itself. So I'm going to put down a geo node, go in there and add a tube. And I'll just make this a height of 10 and turn it to a polygon, give it about 36 rows and maybe 30 columns. I'm also going to add a transform node to the end of this and set that to 90 degrees rotation Z, and template my original one so I can see both, and move the new one over so they're just intersecting a little bit. And what we're going to do here is pretend that the cloth would probably be around this vertical one, and we want to carve some space out of it so that when this collider comes in, the cloth has somewhere to go and doesn't get caught intersecting between these two objects. The way we'll do that is we'll take our transform node and I'm going to add in a VDB from polygons. And that will give us some, well, actually that doesn't give us anything. I need to go back to my original tube and make sure that I have end caps, since the VDB from polygons is only going to work with a closed shape. If I didn't have that, I could also come down here and above the and under the transform node, just add a polycap. And that would put caps on this, and again, that would make the VDB from polygons work. And that'll probably be something that you do as well. In this case, I don't need the polyfill, and I'll just put end caps on. Now I'm going to add a wrangle in, and the first input to the wrangle is going to be the geometry that I want to carve away. So in this case, my original tube. And the second input is going to be this VDB cylinder. And I'm just going to call this push SDF. And I will also turn on a template of the second cylinder so we can see where it is. So what we want to do is use the SDF of this horizontal cylinder to push away this vertical cylinder. And the bit of vex to do this is probably some of the most common expressions that I would use. So to start, we're going to get a float called distance. And this we're going to use a vex command called volume sample, which is going to look at the input and get its distance value, or basically how far away from the surface are we. So the syntax for this is we need the second input, so that's this from the VDB. We need to know which specific primitive we're working with. Well, if we look at this VDB in the geometry spreadsheet, you can see we only have one primitive in there named surface, which is this one right here. That's 0, so that's our first input. And then we want to sample at a specific position. Well, what position do we want to sample at? We want to sample at of all the points in this tube. So I will put at P, and that's going to give me a distance value. Now, if I bring this over to an attribute so I can actually look at it, I'm just going to open up a geometry spreadsheet down here. All right, and we'll look at this, and I'll fix up my expression. All right, and now you can see our distances, and they range from -3 to 0.3. As far as VDBs are concerned, anything below 0 is inside the surface, and anything above 0 is outside. What we'll do is we'll add another line, and we want to know not just how far inside the surface we are, but what direction can we get to the surface. So for that, we can use a very similar command. We're going to say vector grad, and this is volume gradient. And the volume gradient takes the exact same inputs. So it's going to be 1 for the second input, 0 for the surface primitive, and at P for our sample position. And all the volume gradient does is it looks at all the distance values throughout the VDB and figures out, well, say we have one that's in here, and that might be -0.2, and we have one that's on the surface that's 0, it will give us a vector pointing from -2 to 0. So essentially, it gives us a vector from whatever point is inside this directly onto the surface of this shape. So the first thing we can do is just visualize exactly what that gradient's going to give us. So I can make a vector attribute. We'll just say that that is grad, and I'm going to add a visualize node in here. And on the visualize node, we'll just say show me grad, and we want a marker, and we want a vector. And you can see that all these points that were inside of this cylinder are now going to get moved outside of that. So we go back to this push SDF, and the last little bit of thing we have to do here is we first say an if statement. And the if statement is because we only want to move points that are inside the cylinder. So we say if distance is less than 0, well, we want to shift things outside. So we're going to change our position. And we're basically going to say we want to move the distance to the surface in the direction of the vector. Now I realize I forgot one thing here. The vector that we want to get back from here, we want to be normalized because the distance itself is going to give us the amplitude. So I can just add a normalize around this volume gradient. Okay, and as I do that, you can see that these points have in fact moved to the edge of the surface. However, there's still some points that are inside. And the points that are inside are there because the VDB from polygons by default does not make voxels all the way inside. It's only going to do this interior band. We want to know no matter how far inside we are, that we're going to get pushed outside. So what we can do is click fill interior, and that's going to make sure there's voxels all the way throughout there. And that does what we want. That cuts this outer cylinder away to make room for the inner cylinder. Even though we've done that, we still don't have quite enough room here. So we want to add a little bit of extra room. Now, if you've worked a lot with VDBs before, you'll know that there's this VDB reshape SDF node. And if I put this on here, what happens is I can dilate and move up the thickness of this polygon. However, this isn't really going to help us because if I connect this and we look, you can see that once again, we have polygons in the middle of this cylinder. You can see right there. And that's because the VDB reshape does not fill interior like the original VDB from polygons. So if we want to be able to reshape it but keep the interior, we have to do it with something else. And basically, we can just use a volume wrangle. Put that down here. And we're going to artificially increase the size of our VDB. If you remember, the primitive we were using is surface. And as far as VDBs are concerned, anything inside is negative and anything outside is positive. So if we want to increase this, we can say, well, let's say a voxel out here is 0.5. If we subtract 0.5, that'll become 0, and that's our new surface. So I can go to my wrangle and just say, well, I want to work on the surface primitive, and then I want to say subtract something like 0.1, and that will increase this out 0.1 voxels. One thing to be careful here is that you have enough exterior voxels to increase into. So if I really tried to increase this a lot, we wouldn't get anything because I'm now going outside of the exterior band that I have available. If I increase this, we'd eventually start to see something again. I'll set this back to 0.1, and now we'll look at the push SDF, and I'll bring in the original on top of that, and you can see that I've now left space to have some cloth sit. So when cloth is in there, it's not going to get pushed inside this object by the other one. Now the nice thing about this isn't any sort of solver, and it can just work on whatever frame you're at. So if I come back to the transform node, and let's just move this in real time, you can see that it's cutting away the surface. Now there are some limits here. Once more or less this object gets halfway through, you're not really going to get a good result because the closest thing to the surface is actually the other side. So this isn't perfect, but it does work for cutting away one sort of object.